Hey guys, welcome back to geometry. Last time we were together, we were talking about segment proofs, proving segment relationships. This time we're going to be talking about proving angle relationships. Now the rules are the same. Start with the given and exactly on what we're trying to prove. Move one step at a time, only combine things if it's the same justification and the same intent. Have a justification for every single step that you make and kind of have a plan in place before you get started. Okay, so let's take a look at these. So we're given that angles 1 and 3 are complementary. So first have an idea in mind that complementary means they add up to 90 degrees. Angles 2 and 3 are also complementary. Same thing. We want to prove that angle 1 and angle 2 are congruent. Now, we don't have a diagram here, but we don't really need one. We know that these two are complementary. We know that these two are complementary. So the difference between these is 1 and 2. And those are the ones that I'm trying to prove are congruent. Well, they're both complementary to the same angle, so I think that's something that we're going to use along the way. So let's get right to it. Now I have all of the statements here for us. We just need to come up with the reasons. So the first statement, they list all of the given information. Now, how do we know that? It's given. We always know that given will be our very first reason every single time, guaranteed. Next up, statement 2, they say measure of angle 1 plus measure of angle 3 equals 90 degrees. Measure of angle 2 plus measure of angle 3 equals 90 degrees. Well, guys, that's the definition of complementary angles. Okay, if we know that angles are complementary, we know their measures add up to 90 degrees. Now, the next statement, they say measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. So I took these two sums and set them equal to one another. The reason that we can do that is they're both equal to 90 degrees. Since they're both equal to the same thing, I can say they're equal to each other by the substitution property. Okay, next up, we go from this equation with those two sums equal to one another, and then suddenly the measure of angle 3's disappear, and I have just measure of angle 1 equals the measure of angle 2. And I want to think about how that could possibly happen. Well, these measure of angle 3's don't just disappear on their own. The way I would get rid of them is by subtracting them from both sides. And if I subtract the measure of angle 3 from each side, the property that says that I can do that is the subtraction property of equality. Okay. Now, next up, we go from saying that the measures of those two angles are equal to saying that they are congruent. Now, there is a difference between saying that their measures are equal and the two angles are congruent. And the reason that we're allowed to make this jump, we talked about the same thing with segments, it's the definition of congruent angles. Same thing as it was with segments, that's what it means for them to be congruent. If their measures are the same, then they are congruent. Since this proof's done, we can put the QED at the bottom, and we can move on to the next one. Now in this one, we do have a diagram, so we'll see how that helps us out here. We have that angle 1 and 2 are supplementary, so 1 and 2 are supplementary. We have angles 3 and 4 are also supplementary, and we have angle 1 is congruent to angle 4. Now that seems important, so I'm going to put that on the diagram. Angle 1 and angle 4 are congruent. Okay, and I want to prove that angle 2 and angle 3 are congruent. So I'm going to star those so those kind of stand out a little bit. Okay, so now next up, I want to get to it. Now, before I start going through the whole proof, I want to kind of get a plan in place. So I have the 1 and 2 are congruent. I have the 3 and 4, excuse me, supplementary. I have the 3 and 4 supplementary. I want to prove that 1 and 4 are congruent. Oh, sorry. I'm given that 1 and 4 are congruent. I want to prove that angle 2 and 3 are congruent. So I have supplementary, and I have another set of supplementary. To me, that says adds up to 180. If they both add up to 180, that means I'm going to be able to say they're equal to one another. And then maybe I can use the fact that these two are congruent to get those out of the equation and say that these two are finally congruent. That's kind of my plan. We'll see how it goes. Look at the statements. We'll come up with the reasons. So we know that reason number one is always going to be given. And look, angle 1 and 2 are supplementary, 3 and 4 are supplementary, angle 1 is congruent to angle 4. That's all of the given information. We know that will always be our first step and our first reason. Next up, I have the measure of angle 1 is equal to the measure of angle 4. Now, the difference between this line and this line is I go from a congruent statement to an equation. And the reason that we're allowed to do that is the definition of congruent angles. Okay, that's what it means for angles to be congruent. They have the same measure. Next up, on this line kind of scrunched together, I have the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Now that's just the definition of supplementary angles. Okay, supplementary angles add up to 180 degrees. That's the definition. So now I have the measure of angle 1 plus the measure of angle 2 equals measure of angle 3 plus measure of angle 4. This is really similar to the last one. Okay, they're both adding up to 180, so I can say that those two sums are equal to each other by the substitution property. Now, much like the last one, the difference from line 4 to line 5 is that angle 1 and angle 4 disappear. Now, the reason that I'm allowed to do that, measure of angle 1 equals the measure of angle 4, so I can subtract that from both sides. Okay, now remember, the subtraction property of equality says you can subtract the same thing from both sides. But since measure of angle 1 equals measure of angle 4, we are subtracting the same thing from both sides. That's the subtraction property of equality. Okay, then finally, we go from measure of angle 2 equals measure of angle 3 to saying that angle 2 is congruent to angle 3. And the difference between saying their measures are equal and that the angles are congruent is an equation deals with quantities. These measures are numbers, whereas these angles are figures. So equation says that the quantities are the same, congruent says that the figures are the same. And the reason we're allowed to make that change is the definition of congruent angles. And we've proved what we set out to prove, so we're ready to move on. Before we do, though, I want to point something out about this proof. We've just proven that if you have two angles, angle 2 and angle 3, that are both supplementary to the same angle, or in this case, congruent angles, angle 1 and angle 4, those two angles are going to be congruent to one another. So that actually gives us a property that we can use in later proofs. Okay, we can say angles supplementary to the same angle or congruent angles are congruent. Okay, angle 2 and angle 3 were supplementary to angles 1 and angle 4. Angle 1 and angle 4 are congruent. This is going to work no matter what. So since we have just proved that this has to happen, we get to use this statement as a reason in proofs whenever we need to. Okay, so let's take a look at another proof. Okay, we have here that angle 1 and angle 2 form a linear pair. Measure of angle 1 plus measure of angle 3 equals 180 degrees. Now, angle 1 and angle 2 adding up to 180 degrees, that means they're supplementary. And we have that angle 2, we want to prove that angle 2 is congruent to angle 3. So we start the same place we always do. We rewrite the given on statement 1, and our reason is that it's given. Okay, now, from saying that they form a linear pair, we can go back to that list of properties that we have that says that angles who are form a linear pair are supplementary. Okay, and I believe that's called the supplement theorem. Okay, now we have that angles 1 and angle 3 are supplementary. So measure of angle 1 plus measure of angle 3 are supplementary. That's what we just talked about the definition of supplementary angles. Okay, now we have angle 1 and angle 2 are supplementary. We have angle 1 and angle 3 are supplementary. So angle 2 and 3 are both supplementary to angle 1. Now what we just proved in that last one is that if two angles are supplementary to the same angle, then those two angles must be congruent. That's what we're trying to prove. We can use that reason. Okay, two angles supplementary to the same angle are congruent. Now, this is something that we're going to do a few times, quite a bit actually, throughout this course. We're going to prove one thing has to be true, and then we get to use that as reasons in future proofs. Okay. Now remember with these angle proofs, guys, the rules are the same as they were with segment proofs. Rule number one, always start with the given as your statement and as your reason. Always end on exactly what you're trying to prove. Okay, go one step at a time. Only combine steps if they have the same reason and the same intent. Always have a reason for every single statement you make. You have to have a justification and have kind of a goal in mind of how you're going to go through these rules or these the proof before you get started. Okay.